Hello, everybody. Thanks for joining me today. So we are going to continue our discussion in Chapter 7, Section 1, and we're going to continue talking about how to simplify expressions using the properties of exponents. And if you recall what we went over yesterday, we went over three different rules. We had a product property, we had a power property, and then we had a power of a product property. And the main examples I showed you yesterday use the product property of exponents. So I want to show you a few more examples, actually six to be exact, that will utilize those other properties that we discussed from the previous video. So number 5, you can see we have this expression. It says y squared and then the quantity to the third power. Now, if you go back to your properties and look which one that is the second one. That is the power property. And what that allows us to do is if you have a power to a power, it allows you to write the base once and then just multiply the two powers together. So that's what we're going to do here. So we have y squared to the third, and what's that going to become is y to the third times 3. And so again, you don't have to write that. If you want to just write y to the sixth, I'm perfectly fine with you doing that. I'm doing it to show you how the powers are going to combine. So there you go. That's all there is to that one. Number 6 is in a similar fashion. However, we actually have to utilize two properties. We're going to utilize both of these properties. The reason being is, yes, we have a power to a power, but we also have multiple things inside the parentheses. And what the power of product property tells us is that if there are multiple things inside the parentheses, as long as they're separated by multiplication, you can put each of those bases to the m power. So that's what we're going to do. Now, they each have an existing power. You have to multiply the powers together. So it's kind of the next one is a combination of the power property as well as the power of product property. So let's take a look at this. This 2 is going to go ahead and multiply the 3 and the 4. Now it can do that because the r and the s are separated by multiplication. I cannot stress that enough. You can only do this property when the expression has multiplication inside the parentheses or division, not addition or subtraction. Really, really important. So what this becomes is it becomes r to the 3 times 2 and then times s to the 4 times 2, like that. So this becomes r to the 6th, s to the 8th power. And that's what we end up with. So there you go. Not too difficult. Now, the next couple get a little bit more complicated. And the only reason why it's more complicated is there's more numbers inside the parentheses. First thing we're going to check, all of the things inside the parentheses are separated by multiplication. So that means this 2 can go ahead and distribute to everything. Now, if you recall in the last video, I did say that if you have a variable without a power, that you should go ahead and write the number 1 in for the power because it is 1. That same advice goes for numbers as well. So that 4, you see the 4 right there, it does not have a power on it. So I'm going to write a number 1 there. And it's important to remember that that is 4 to the first power because this 2 distributes to every single power inside the parentheses. So every one of those numbers that you see that I drew an arrow to gets multiplied by 2. So we end up with 4 to the second. Then we have a to the fourth, because 2 times 2 is 4. Then we have b to the eighth. 4 times 2 is 8. And then we have c to the 10th power. 5 times 2 is 10. So 4 squared times a to the fourth, b to the eighth, c to the 10th. Now we are going to clean up the 4 squared. The 4 squared is 4 times 4, which is 16. So I'm going to write 16, a to the fourth, b to the eighth, c to the 10th, just like that. And there's our final answer. So not too bad. The next one we're going to do is very similar to the last one. You can see I have this expression inside the set of parentheses. Once again, there is a base number. It's -2, so I am going to make that -2 to the first power. And then this 3 is going to go ahead and multiply all three things. I actually would encourage you to draw your arrows like that so you remember to multiply every single exponent inside by that 3. So it's going to be -2 to the third. Now I'm going to put parentheses around there because of the -2. The next one is going to be f. Now 3 times 7 is 21. And then g, 4 times 3 is 12. And then h is 2 times 3, which is 6. So we have -2 to the third times f to the 21st, g to the 12th, and h to the 6th power. I am going to clean up the -2. If you ever have a base number to a power, you should write that number out. And so -2 times -2 times -2, -2 times -2 is +4. +4 times -2 is -8. So this becomes -8, f to the 21st, g to the 12th, h to the 6th, just like that. Now, number 9 and number 10 are the last two we're going to take a look at. These are the most complicated ones on this worksheet. And so there's a lot going on here. We have two different algebraic expressions that are being multiplied together, and one of them has a power on the outside. So there's a lot going on. The first thing I'm going to do is I'm going to go through and write a 1 on everything that does not have an exponent. So I have 4 to the first, and then 2 to the first, and a to the first, and c to the first. And you'll see why I'm doing that in a second. The next thing I need to do before I can drop the parentheses and reorder everything to get all the like terms together to then begin to get them to put together is I've got to get rid of this 2 on the outside. So once again, this is a power to a power. So this is going to multiply every single number that you see right there, just like that. So 1, 2, 4, and 5. So I'm going to have 4 to the second, and then a to the fourth. Now b, it was b to the fourth, but it becomes b to the eighth because we multiplied it by 2, and then c to the 10th, like that. Okay. Now the next thing we're going to have is 2 to the first, a to the first, b to the second, c to the first. Now you can see that I put those ones in there on purpose because once we reorder, which is going to be the next step, you won't hopefully forget to utilize those when they get combined. So I'm going to go ahead and do a couple things here. I'm going to make the 4 to the second power. That means 4 squared, which is 4 times 4. That's 16. So I'm going to go ahead and write that 16 right here. I'm also going to write the 2 to the first. Okay, so 16 times 2 to the first. And as I use these, I'm going to go ahead and cross them off so I don't forget them. When you get these expressions that have a ton of different variables and numbers in them, it's not a bad idea to check them off as you're using them. The next thing I'm going to do is alphabetize the letters. So I'm going to have a to the fourth and then a to the first. Check those off. Then I'm going to have b to the eighth and b to the second. Check those off. And then c to the 10th and c to the first. Check those off. All right, so now we have the entire expression expanded and then organized based on like terms. So the last thing to do is going to be to combine our like terms. So we have 16 times 2, which is going to be 32. And then remember, when you have two bases that are the same and they're multiplying, you add their power. So I'm going to add the a to the fourth and the a to the first, and it becomes a to the fifth power. Same with the b's. I have b to the eighth and b to the second. Those are going to add up and become b to the 10th. And then the last one, I have c to the 10th and c to the first. Those become c to the 11th power. So now we have our final expression with everything condensed down as far as it can go. All right, so the last example I'm going to show you is a power to a power to a power. So what you see is we have 2 to the second, to the second, to the second. All right, so what happens is the rule states that when you have an exponent to a power, which is right here, says the power of a product. That's not the one we want to look at. We want to look at this one, power. And I call it a power to a power because that's what you have. You're going to multiply all of the exponents. So that's simple. Let's do that. So what we have here, and I'll work from the outside in. I'm going to take this 2 and multiply this 2. It's going to multiply this. Now, here's the thing to remember. It does not distribute all the way in, okay? It only multiplies the power immediately inside. So 2 times 2 is 4. So what we end up with is 2 squared and then to the 4th power. So this 2 goes in and multiplies the first inner 2, and it becomes 4. Now we're going to do the same thing. This 4 is going to go ahead and multiply that 2 right there, and I'm going to write 2 to the 8th power. And then there is my final answer, 2 to the 8th. All right, guys. So hopefully that made sense to you. And as always, if you have any questions, feel free to email me. Have a great day.